Hey there, Professor Sills here, and what I'd like to do is debrief you on activity 3.2. You can see that the main idea of 3.2, or at least one of the initial ideas, is to help you understand the difference between a hazard and a risk. Think of it this way: if you go to the beach and there are riptides, that's the hazard, the riptide. The risk would be the probability of you having a problem if you go in the water and get caught in a riptide. And that might be a function of your knowledge, your background, your swimming ability. When I say your background, your ability to read the waters, and your knowledge of how to get out of it. So risks can vary, hazards are just identifiable. So with that said, we're now looking at the top 10 hurricanes in the basically over the last 100 years, during the majority of the 20th century. So what we're going to do is we've got the top 10 tracks theme activated. Notice it's highlighted here, it's raised, and I'm going to turn it on. So with that, what it asks us to do is determine the path length of most of these storms, the average path length. And what you have to understand is that these storm tracks actually are drawn from a database, and when it tells us to go to field to open the theme table right here is the database that contains all the information. You've got the year of the storm, the amount of damage it caused in $1998, the deaths that resulted from it, and the path length. And you can see that what I'm doing here is following the instructions and highlighting the path length column or data entry area, so that we can then run a statistical analysis on it. That's one of the powerful things of a GIS. It'll run statistics for you. So here we can see that the maximum was 10,000 kilometers. The mean or average is about 6,000 kilometers. So that would be the answer to question number 2. Now, to compare that to all U.S. hurricanes, we're going to back out and turn things off. We're going to turn off the top 10 tracks. We're going to go down here to the Atlantic hurricanes, and all that spaghetti represents all the hurricanes, but we also have to activate the theme. Forgive my cough here. So we activate the theme, and we can go back to the theme table. We scroll all the way over because you can see that these happen to have more data in them, and you can feel free to sort by data and really analyze it. So again, we're going to highlight path length, and we're going to go to field statistics. And again, this is more to give you a feeling for what you can do with this, and you can see that the mean is about 5,000 kilometers. So that just gives you a sense of what we're doing here. I'm going to pause the video as I read through the next page and prepare to be able to give you some solutions. Okay, so what I've done here is I've made the statistics table a little wider, the theme table a little wider, and what we're looking at is all of the hurricanes, and I'll scroll over to the right. You've got the path length that you can see here, and we have a sort tool, so we'll just sort it from long to short. So you've got about 13,000 kilometers, 12,874 is the maximum, and if we scroll down, it goes all the way down to 280. Now, the question that you're asked here in number 4, I'm on page 48, is do you see any relationship between a hurricane's path and its intensity? Well, the category here tells us its intensity, and H3 would be at its peak, it was a category 3, H4 a category 4, H5 a category 5. So we've got some pretty hefty storms that seem to have longer travels over the ocean. And if we scroll down to the other end of the spectrum, there may or may not be a trend here. It looks like there probably is. I mean, we see an H5, category 5 here with just a 1,700 kilometer length, but a lot of the others are just category 1s and 2s. So you can draw your own conclusion on this. I would tend to say, yeah, the longer they travel, the stronger they are at their peak, but realize that's at their peak. Now, the next thing it asks you to do is really kind of get a feel for how frequently the East Coast and the Gulf Coast gets hit by hurricanes. So let's back out of here and let's turn off the Atlantic hurricane theme and just bring up the media viewer as it says and bring up the Gulf Coast landfalls, and I'll center this over where you can see it, and we'll bring up the Atlantic landfalls. And just to spend a moment on the Atlantic landfalls, you can see that the New York metro area and Long Island certainly have had their share of hits during the 20th century, the second half of the 20th century. But you can see that just by eyeballing it, the booby prize, if you will, goes to North Carolina. And that should be no great surprise because of where the land stretches out to and because of the shape of the eastern seaboard, particularly through North Carolina. South Carolina, of course, has had a few hits, and you see just one here in Georgia and one here in North Florida. Now, looking at the rest of the Gulf in particular, I'll bring that view up. You can see that certainly South Florida all the way around the Horn has had some activity, and you can count these up. Looks like, well, Florida, of course, has over 1,000 miles of coastline, so that's got to be taken into account if you're going to consider Florida as an entire state. And then you look at Alabama, which has this little piece, and Mississippi has this little piece, and then, of course, a fair amount of Louisiana has coastline, and, of course, a lot of Texas has coastline. So you can add these up, and you can even do a color analysis if you want to really kind of identify, well, where did the most severe storms hit? So you can get the idea with number 5. You could really play this thing out. But, you know, hopefully you took out a few minutes and you colored the thing in, and you had a good time really analyzing where these storms are most prevalent. So again, I'm going to pause this, and we're going to pick up with page 49 in a moment. So I'm looking at question 6 here. I'm looking at question 6, and I'm seeing that they're asking us to analyze a relationship here between the number of people who are killed in a storm versus the year the storm occurred. And what I've already done is I've categorized this so that the greatest number of deaths is up top and then down to 0. And if you eyeball it, you can see, well, the Galveston storm was 8,000 in 1900. And remember, we began this unit with that being really one of the poster child storms. We see that there were very few deaths in the latter part of the 20th century. And in the United States, that's really how it should be. Katrina, of course, was an exception to the rule. And I think if you look up the political situation and the infrastructure of New Orleans and the way the people were prepared for that storm by the locals, that would begin to explain why over 1,000 people were killed in that storm. But nevertheless, if we consider other areas of the world, for example, in Central America, every year, and just this year as I'm recording this, 2010, there's always a storm that hits Central America at least once a year or every other year. And Central America, for a number of reasons, first of all, look at the mountains here, that's the brown. That tends to exaggerate or enhance the rainfall. The second thing is the infrastructure in Central America does not begin to compare to that in the United States. I mean, a well-organized city, Houston is a great example, Miami is another great example, where you have local leadership that recognizes the risk and the harm, the potential harm. What'll happen is the interstate highway system acts to help people be able to leave harm's way while there is out. So one of the things that is ask questions and then use the analysis tools to answer those questions. So in interestingly, this data that you're looking at is all pre-2004-2005, when Florida seemed to be the bowling alley for all of these storms. But we're going to see exactly how prevalent they are even prior to that time period. So it says here we need to go to the states theme, which of course the data would be all of the states. And we're going to use the select feature tool right up here. That's right, we need to select Florida. And then we're going to activate the we're going to do the select by theme dialog. Theme, select by theme. And we have to set this up so that we're going to have an intersection of states and the top 10 tracks. You can see immediately we've highlighted the tracks that cross Florida. See all of these storms, at one point or another, tracked across Florida. Now, when we move on to page 50, we can begin to analyze the data a little bit further, and we're asked to bring up the theme table. And you can see that there are 6 tracks that are highlighted, but you can also see that up here, because if you were dealing with a larger quantity, you wouldn't want to have to count those out. So you can see exactly how prevalent these are. So following along, if we want to know how much damage was caused, we can highlight the damage field, and we can go to Field Statistics, and we can see that the of billions. That would be 100. What am I looking at here? Easier to write the number out and put the zeros in there. If I got this right, that's 100,000. That'd be million. Almost $3 billion as the average figure in 1998 dollars. If I've got that right, a little bit of artist license here as I'm doing this on the fly. When it makes landfall, the 90% of the damage is going to be in the area where it made landfall. That would be a rough generalization, because there could be that's could simply take 90%. Is where they happen to hit, whether they hit a metro area or whether they hit a fairly sparse area. Where I am in West Palm Beach, you go to this area and there's very, very few people actually to be found. As far as who pays for the damages, to some degree that's local and state, but to a great degree the federal government steps in, declares a state of emergency, and where we have a shared risk nationwide. And of course, is that we also benefit by having these areas in our country, so we tend to take care of the infrastructure in these areas when they get hit. So it should pretty well take care of this activity, and look for another video which will address 3.4.